Algebra II 3.78, determine if two lines are parallel, and a theorem. Now, if you haven't seen the previous videos for Chapter 3, you may get confused, okay? And there's links in this video description to take you to those, all right? Lines are parallel when they never touch, no matter how far out we draw them. It's easy to see parallel lines when they're graphed, but how can we be sure the lines are really parallel? What if they only look parallel? Well, their slopes are going to let us know. So look at these two lines. Now, if you looked at them quickly, you'd say, yeah, they look parallel. But if you look closely, you can see this one has a rise of 7, and this one has a rise of 8. This one is a rise of 7 and a run of 15. And this one has a rise of 8 and a run of 15. And they look like they could be parallel, but they're different slopes. They're slightly off. So the slope is going to definitely tell us if they're parallel or not, okay? When we graph a pair of equations on the same axis, there's three possibilities. There's three things that can happen, okay? The equations will have the same graph. The graphs will intersect at exactly one point. They'll cross each other. Or the graphs are going to be parallel lines. And that brings us to another theorem. So here's the other theorem I've got for you. It's for parallel lines. Two non-vertical lines are parallel if and only if they have the same slope and different y-intercepts. That means if they're in the slope-intercept form of an equation, they're going to have the same m but a different b, okay? So they're going to have the same m but a different b when they're in this slope-intercept form of an equation. So are the graphs of these equations parallel? Well, this one is in slope-intercept form, and we can see the slope is a -3 and the y-intercept b is a 5. But this one says 4y equals -12x plus 20. So we divide each of these terms by 4 to get rid of this coefficient 4. And that makes our buddy the invisible 1, doesn't it? Right here. So we have 1y, and our slope is a -12 rise over a 4 run, which gives us a -3x, and 20 divided by 4 is a 5. And if you look at these two, they not only have the same slope, but they have the same y-intercept. Well, if you have the same slope and the same y-intercept, you're going to have exactly the same line. It's going to be one line on top of the other line. So if you look at this right here, if they both had a y-intercept of a +5, that means they're both going to hit +5 right here on the y-intercept, on the y-axis. See? If they both are hitting the y-intercept at exactly the same place with the same slope, it's going to be exactly the same line. When the equations are the same, one graph is laying on top of the other. So no, they're not parallel. Okay? Now look at these. Are the graphs of these equations parallel? So here's one, and here's the other one. So this one needs to have the y in the front, right? It needs to isolate the y. So for this -3x, we're going to take it away from here and eliminate it by adding a 3x to each side of the equation. That's going to create the zero pair right here, right? And now we've got y equals 3x plus 1. So now that's going to be our pink line. On this side, we've got a coefficient of a -2 here that we need to get rid of. So we're going to divide each term of the equation by that -2 coefficient. Remember, terms are split up by plus and minus signs, okay? Addition and subtraction signs. So there's a term here and a term here. So now we have three things that need to be divided by -2. And when we do that, we create our buddy, the 1, right? Negative over a negative, two negatives divided are going to make a +1, so we have a positive y. This is going to be a -3/2 slope, and this is going to be a -1 because the positive and the negative divided makes the -1, doesn't it? So now look, here's our first one, and here's our second one. So the first pink line graphed is going to have a slope of 3, and it's going to hit the y-axis at +1. So that's right here. It's hitting the y-axis at the +1, and it's got a slope of 3, doesn't it? So we can do 3 over 1 as our rise over our run to make a 3. So the run is a 1, and the rise is 1, 2, 3. So this pink line is graphed like this, see? Now, this one has a negative slope. And remember what I've always said? If the slope is positive, the line rises to the right. And if the slope is negative, it's going to fall to the right. So we know that this line is going to fall, isn't it? And the slope is a -3 rise. So that means it's going to go down 3. 1, 2, 3. And the run is a 2, isn't it? So it's going to go 1, 2. So that's our blue line graphed. And no, they're not parallel. They have to have the same slope m, but a different b. They don't have the same slope, do they? No, so they're not parallel, okay? How about these? Are the graphs of these equations parallel? So we've got 3x minus y equals a -5. So we need to put it in slope-intercept form, don't we? So let's get this y by itself by getting rid of this 3 here. So we add a -3 to each side, creates a 0 pair, gets rid of it. So now on this side we have the -y, and on this side, to be in slope-intercept form, remember, the x has to come before the red b, doesn't it? So this minus 3x is going to come in front, and then we're going to have the -5, aren't we? And if you also remember, when there's a negative sign here, for negative of y, there's really a 1 here, isn't there? There's an invisible 1. So to get rid of this negative sign, we can divide each term by -1. That's going to be a negative divided by a negative. That's going to make a +1 y. And this is going to make a +3, and that's going to make a +5. So now this is our equation for our pink line. On this side, we need to get it in slope-intercept form. So for this -3x, we can add 3x to each side, create a 0 pair, eliminate it. And then on this side, we get 3x minus 2. So now when we look at them, remember, they have to have the same slope m, but different b, y-intercept, okay? Well, 3x, look, they have the same slope m3, don't they? The m value is a 3 for both of them. So they have the same slope, and look at this one has a +5 and this has a -2. So they have different y-axis intercepts for b, don't they? So yeah, these are parallel. This one is going to be a run of 1 and a rise of 3, isn't it? 3 over 1. And it's going to hit the y-intercept at the +5. And look at that, it does. It hits it right at the +5. This one is going to hit the y-intercept at the -2. So that's down here. And it's going to also have a rise over run of 3. And when we graph these two lines, we see they're parallel. They both have the same slope m, but different y-intercept b values. So yeah, these are parallel, okay? All right, our next video is 3.7b. We're going to talk about finding equations of parallel lines. And of course, you can go to the description of this video to see the previous ones. There's a link for the Algebra II playlist, so you can use it for studying. And I'm going to add this video to it. And you can also go to the Chapter 7 playlist for graphs and linear equations from my Algebra I playlist, and that's just going to be the chapter, okay? So you can go back to Algebra I if you're really confused, okay? All right, so I hope this was helpful. I hope you're doing okay. I hope I explained it well enough. I always worry about that, and I hope I'll see you in the next video. Bye.